Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google. I'm originally from Cyprus, as he explained, but I live in London. And today I'm going to be talking about serverless containers with Knative and Cloud Run. Before I start my talk, everything that I'm going to talk about today, the slides and also the demos that I'm going to show, it's already on GitHub on this link. And there's a QR code for it, so you don't have to take any pictures. Just go to that link and you have everything and more that I'm going to show here today. And today we have 60 minutes, which is great. That leaves me a lot of time to show everything I know about Knative to you. And hopefully in the end, we're going to have some time for questions as well. So feel free to save some questions if you have any. All right. So the way I start my talks is that first I want to set the stage for people. So I'll do a little bit of introduction at the beginning of the landscape for Knative and cloud native technologies in general. So if you already know Kubernetes, just hang in there. I just want to make sure that everyone is on the same page. Then after that, we're going to do a little bit of introduction to Knative, and then it's going to be very much demo-driven talk. So I'm going to show you a bunch of demos on Knative and how it works. Okay? So first, let's do a little intro. What is Knative? Knative, the official definition is, it's a Kubernetes-based open source building blocks for serverless, right? And there's two bold sections here, Kubernetes and serverless. Now, if you know anything about Kubernetes, this sentence probably doesn't make sense because in Kubernetes, you have what's called nodes. And these nodes are, if you're running locally, it's physical servers. Or if you're running in the cloud, they're virtual machines. So there are servers that you need to think about. You can't just abstract them away just because you're using Kubernetes. But that's the whole point of Knative. Knative, it tries to take Kubernetes and turn into a serverless platform so that most people using Knative, they don't necessarily care about the fact that there's a Kubernetes behind the scenes. So that's what Knative tries to do. Now, let's first define serverless a little bit and then talk about Kubernetes a little bit so that everyone is on the same page, and then we're going to get into details of Knative. Now, serverless, it's a funny term because depending on who you talk to, you get a full range of definitions. Now, for some people, it's basically anything that runs as a service that you don't care about servers is serverless. For some other people, it's basically event-driven functions, and that's it. But I think it really doesn't matter. Like for me, when I think about an ideal serverless frameworks, there's some certain characteristics that I look for, and those characteristics are like this. First of all, when you're dealing with a serverless framework, you shouldn't care about servers. Obviously, there's some service somewhere, and obviously it's someone else's problem, but it shouldn't be my problem as someone consuming this serverless technology. Now, the second thing is the serverless framework should be idiomatic, meaning, I'm a C# developer. I'm used to using ASP.NET Core web framework nowadays. So I should be able to use that in my serverless framework, right? I shouldn't have to kind of use a special framework because it's serverless. When we talk about serverless, it's usually event-driven. So something triggers your function or something triggers your container rather than synchronous. That's what we kind of expect from serverless frameworks. And then finally, it would be nice for your serverless framework to be portable, meaning, if you write your function or your container and deploy in a serverless way on Google Cloud, you should be able to take the same thing and deploy to Kubernetes running locally or AWS or Azure. It would be nice to be able to do that. You don't want to rewrite everything just because you want to use one serverless framework versus another one. Now, when you look at Knative, I think it does a pretty good job of providing all these ideal serverless pillars, and hopefully by the end of this talk, you will see that it gives you all these things that you kind of expect from an ideal serverless framework. Now, I'm sure most of you know or heard of Kubernetes, but just to recap so that we are all on the same page, if you want to deploy your microservice on Kubernetes, you had to do a lot of things, right? First, you start with a container. You take your code, you containerize it, and you create a container image out of it, and you push that image to a container registry, like Docker Hub or Google Container Registry or Azure Container Registry or something like that. Now, in Kubernetes, you don't schedule containers, you schedule what's called pods. A pod is typically a single container, but it can be multiple containers scheduled together. So you create this pod template that defines what you want to be scheduled in Kubernetes. Then you tell Kubernetes what you want to be true. In this case, the replication controller or the replica set, we are telling replica set that we want to have 3 copies of these pods. Then Kubernetes looks at your pod template, it creates these 3 pods, and it schedules them on the nodes that you have. So the scheduling now becomes a problem for Kubernetes, not for you. These nodes, these servers, either physical machines running locally or virtual machines running in the cloud. But either way, you have these nodes that you have to think about. And these pods are running. You can add labels to these pods. So in this case, we are adding a couple of labels, role and environment. Then once your pods are running and you want to expose them to the outside world, you create what's called a Kubernetes service. A Kubernetes service has a stable virtual IP or a DNS name, and then people from outside world will get to your service, and from there it will get to your pods. Now, as you can see, it's not a microservice is not just your code anymore. It's a combination of your code containerized and a combination of what Kubernetes provides with replication controllers, scheduling, and running your pods, and the service kind of load balancing your pods, and many other things that Kubernetes provides. Now, when you look at this as an application developer, you really don't care, you know? Or at least you don't want to care. Because as an application developer, all of these are details that take time away from what you want to solve, right? So developers, they love serverless. They love things like Google Cloud Functions or AWS Lambda, because what you do in these frameworks is that you write your code, deploy your code, but you don't necessarily care about how the code is running and how the code is scaled, things like that. Now, on the other hand, if you are someone doing operations, you love Kubernetes, especially if you are running containers, because Kubernetes, it gives you a way to run containers in a resilient and scalable way. It gives you the tools for that. So there is this tension, I think, between developers not wanting to care about Kubernetes and operators wanting to use Kubernetes. And how do you bring these two worlds together? That's been the question with the containerized microservices world. Now, that's the whole point of Knative project. So Knative project, it tries to bridge the gap between application developers and operators so that operators can still use Kubernetes because it's a good technology to use when you're running containers at scale. But at the same time, application developers, they don't have to care about all the underlying details of Kubernetes. And we'll see how this works as we go through some demos later in the talk. It's an open source project on GitHub. And it started by Google, but now a bunch of companies like Red Hat and IBM and SAP and others, they're contributing, so it's very much open source. And you can think of Knative as a set of components for serverless. So it gives you a set of building blocks to run serverless containers on top of Kubernetes. I should also mention here is that some of you, maybe you know or not, but Knative, even though it's an open source project and all the code is new, the concepts are actually within Google. For example, in Google App Engine, which has been around for a long time, there's this notion of revisions and there's this notion of traffic splitting between revisions. So you will see the same notions carry over to Knative. So all the learnings that we did from App Engine and the other projects, they kind of moved into Knative as it made sense. So even though it's a new open source project, the learnings from it is not new. They've been around for a while. All right, so the Knative stack kind of looks like this. First, at the platform layer, at the base layer, we have Kubernetes. So everything runs on Kubernetes. Then on top of Kubernetes, you need to install a gateway. Because Knative, it tries to solve the serverless problem, but it doesn't really try to solve the networking problem. So it doesn't really try to figure out how to get traffic to your containers, how to set rules between your services, things like that. Instead, it relies on some gateways like Istio or Glue or Ambassador to do all those details about networking. So Kubernetes, then on top usually a gateway like Istio. Then on top of that you can install Knative. So Knative has two main components, serving and eventing, that we'll go through. And I should also mention that up until recently, Knative also had a third component called Knative Build, but now Knative Build kind of got out of Knative into a new project called Tecton Pipelines that I'm going to briefly mention at the end of my talk, but I think either today, later today after lunch, there's a talk on Tecton Pipelines, and I think it's called like DevOps on Kubernetes or something like that, where you can learn much more about that as well. Now, so you can use Knative everywhere there's Kubernetes, but typically if you're running in a cloud provider, there are other products that are being built on top of Knative that you would use. For example, on Google Cloud, there's something called Google Cloud Run, which is the managed version of Knative, and there's another thing called Google Cloud Run on Anthos, which is a managed version of Knative on Google Kubernetes Engine, which is the managed version of Kubernetes on Google Cloud. And there's other products from other companies that are being built on top of Knative. So the idea is that if you want to use Knative on pure Kubernetes, you can do that yourself. But if you're running in one of these clouds, you would probably use one of the managed versions because they make it much easier. Now today's talk is about Knative itself, so 90% of my talk will be just about pure Knative, but I will show you one demo of Google Cloud Run so that you get an idea of what it means to run Knative on Google Cloud and how it's different. And hint, it's not that different, it's just easier. All right, so how do you use Knative? Well, first you need a Kubernetes cluster. And depending on where you are, you get Kubernetes cluster in different ways. But on Google Cloud, it's a single command with gcloud command line tool. So you just say gcloud container clusters create, give your cluster a name. Then I specify an add-on. These are the things that I want to install on top of my Kubernetes cluster. And the important thing is that I'm installing Istio on top of Kubernetes cluster. So this gives me a Kubernetes cluster with Istio already installed. Then I define things like the cluster zone and auto-scaling and things like that. But the important thing is that I get Kubernetes with Istio as my dependencies installed. Then I need to give my user admin roles so that Knative things can work. So that's the cluster role binding. And then I just install Knative. And installing Knative is basically just pointing to some YAML files that comes with Knative. I think as of today, 0.9.0 is the latest one, or the latest version of Knative. And if I want to install serving, I just point to serving.yaml. If I want to install eventing, then eventing has a release.yaml for some reason, and I point to that. And then there's also monitoring.yaml that you can point to get some monitoring on Knative. By the way, so here I'm installing serving and eventing at the same time. You don't have to. If you just want to use serving, you can just install serving. So it's up to you basically what part of Knative you want to install. It's not just all or nothing. But in this case, we want to install everything. All right, so let me actually make sure that I have my cluster running before I start showing you my demos. So here I am in Google Cloud. I already created a cluster called Knative09 on GKE, Google Kubernetes Engine. I just want to make sure that my cluster is up and running. So let's make this a little bit bigger so you can see. Oh, what happened? All right, so if I do kubectl, I'll get pods. And Knative gets installed. Knative is just another app running on top of Kubernetes, but it gets installed into separate namespaces. So for Knative serving, it's under Knative serving namespace. So I just want to make sure that the pods of that are running, and they are, which is good. And let's also make sure that the Knative eventing pods are running. So those are running as well. So we are in a good shape when it comes to demos, hopefully. So what I want to do now is I want to talk about Knative serving, the first part of Knative. And then I'm going to show you some demos, and then we're going to keep going with Knative eventing and build. So what is Knative serving? In a nutshell, Knative serving, it gives you a way to deploy containers in a serverless way, right? So what I mean by deploying containers in a serverless way is that, if you're using AWS Lambda or Google Cloud Functions, you basically just define a function, deploy the function, and all the details of how that function is deployed, where that function is running, how the network is, how the traffic is going to that function, how that function is auto-scaled, all that is basically not your problem anymore. It's automatically done for you. So you can think of Knative serving as the same way, except the unit of deployment is a container. It's not just a function, right? So the unit of deployment is a container. This is good in the sense that it gives you much more flexibility than just defining a function, because usually the problem with functions is that, well, what you can do in a function is limited, and also these function runtimes are somewhat limited as well. So you kind of rely on the cloud provider to give you kind of like the language, the version of the language and things like that. You have to kind of fall into that category to be able to use them. Whereas in Knative, as long as you can define, you can create a Docker file, it will basically run that for you. What it gives you is basically, once you deploy your container, it will create a service, it will route the traffic to that service, your service will be automatically scaled, so by default it will run in a single pod, but it will scale down to 0 if no one uses it. If a lot of people use it, it will scale up to n that you can define. You get a basic configuration and revision management with this that I'm going to talk about. And then once you have multiple revisions of your service, you can also do traffic splitting between those revisions in a really easy way. Okay? So that's what Knative serving is in a nutshell. And the terminology of Knative serving is that first you have a service at the top layer. This is a Knative service. It's not a Kubernetes service. Kubernetes service is something separate. This is something at a higher level. It's a Knative service. And then the service has a configuration. The configuration basically has things like the image that you want to deploy or the environment variables that you want to pass into your container. And then once you deploy your service and the configuration, Knative creates a revision. So that's kind of like a snapshot of your service and configuration at one point in time. And then once you have the revision, Knative also creates a route to point to that revision. So all the traffic, all the external traffic goes to that revision. And every time you change something about the configuration, let's say you want to change the environment variable, or if you want to change the container image, point to a new image, that will create a new revision and it will update the route to point to that revision, okay? And then once you have multiple revisions, you can also add rules here so that you can do things like blue-green deployments or traffic splitting or things like that. So that's what Knative serving is about. So let's just look at some examples. As I mentioned, if you go to GitHub, I have a Knative tutorial with the slides, and I show you how to install it on Google Cloud. And then I also have all these samples. So I just want to show you a few of them. First, let's look at a very simple example, because it's good to start simple. What I want to do here is that I want to create a very simple service. When it gets a request, it will reply back with hello world with a version number. And let's see what it takes to actually deploy the service. Now, first, you need to create your code. Here, I show you how to create code in C# or Python. The code is not that interesting, but if we have to look at it, I just want to show you quickly. Basically, we have a startup. In this startup, I'm just saying when I get a request, just look at the environment variable target, and if you have it, just say hello target. If you don't have it, just say hello world. It's very simple. And then I also create a Docker file because I need to containerize my application and push this image to Docker Hub already. So it's very simple, but it will serve as an example on how to deploy this. So that's the code for C# or Python, but it can be any language you want. Then I build my image. I call it Hello World version 1. Then I push my image to Docker Hub. And then I create a Knative service. So this is a Knative service, and you can see that it's using Knative API. The type is a service, Knative service. Name is Hello World. And I'm going to deploy it into default namespace. And then this is the configuration of my service. The first part is the image. So I'm pointing to my image on Docker Hub. And I'm also passing in the environment variable that my code is going to read. So the environment variable is target, and the value is v1, right? So this is the full definition of my service. It's basically the name, the image, and some environment variables, and that's it, nothing else. Now, if you have done Kubernetes, you know that this is much simpler than Kubernetes, right? Because in Kubernetes, you need to create a Kubernetes deployment, then you need to create a Kubernetes service, and that's probably it. But then if you're also using Istio on top, you need to also create Istio gateways to enable port 80 traffic. Then you need to create Istio virtual service to map the traffic to your Kubernetes service. Then you probably also need to create a destination rule to create a version of your service. So you need to do a lot of things to get things right. It's not impossible, but just a lot of YAML files that you have to create. Whereas in Knative, by doing this, I already have my service running on Kubernetes and having Istio point to that service, right? So it's much simpler. So let's deploy this. Let me make this smaller, make this bigger. Is it big enough? Maybe a little bit bigger. Yeah, so let's watch some things first. What I'm doing is that I'm watching Kubernetes pods, Knative service, Knative configuration, Knative revision, and Knative route. And as of now, there's nothing because we haven't deployed nothing. And then in here, let's just deploy the first version of my service, the one that I just showed you. Now this deploys the service, and then you will see that right away, we have a pod that's been created. We have a Knative service with a URL that's already running, the configuration of our service, the first revision of our service, and the route pointing to that service. So all the things that I talked about, it's already created. And then if I do a curl to that URL, it says hello v1. So our service is up and running, which is great. Now, as I mentioned, every time I change configuration, this revision, it creates a new revision and it points route to that revision, right? So let's do that. For example, in here, let's change the environment variable from version 1 to version 2 and see what happens. So I come back here, then kubectl apply, but this time let's do version 2. Now what will happen is that you see that immediately Knative realizes that we did a configuration change. It created a new pod already, and then you can see that I have a new revision, the second revision of my service, and the route has been updated to point to that revision. So if I do a curl again, you see that it says hello v2. So we did a configuration change. Same thing as code change. Let's imagine that you change your code and you want to do an update to your service to use the new code. Now what you need to do is, in this case, instead of saying hello, I'm saying bye. So I changed my message from hello to bye. I built my image. The image name is the same, but then I call this version 3. And then I push my image. Then I come to my service and then change the image that I'm pointing to from version 1 to version 3 and just deploy, right? So that's how I can roll out a change. So let's do that. And then by the way, so I'm applying this. You can see that, I don't know if you saw it, but now we have 2 pods running. One is for version 2 and one is for version 3 that we just deployed. Version 1 is gone because we haven't used it for 60 seconds, so it's scaled down to 0. And because of that, we don't have it anymore, which is nice. But you can see that in the revisions, I have revision 1, revision 2, and revision 3. And then if you do a curl again, it says by 3, so we did a code change. Of course, in the real world, you don't change code like this. You don't just push updates like that, or at least you shouldn't. What you should do is that you should push an update. You should do a silent deploy of your code and test that code, make sure that it works. Once you're confident that it works, you should start sending some of the traffic to that version, and then once everything is working, then you will shift all the traffic to that version. So you want to do blue-green deployments or traffic splitting, whatever you want to call it. Knative makes this kind of things quite easy. So if we look at some traffic splitting rules, first thing that I should mention is that all our revision names so far, they have random names like this. And to do traffic splitting, it basically helps if you have predictable names. And Knative allows you to give predictable version names to your services. So if you come to your service, and then under here, metadata, you can actually give your revisions a name. So in here, I'm saying that when I deploy the service, I want the revision name to be version 1. So I want something to be specific. So that's number 1. And the second thing is that I can also specify some traffic rules. So in here, what I'm saying is that I want the current version of the traffic to be revision v1 that I defined, and I want it to get 100% of the traffic, all of the traffic, and then I want anything after that. So if I deploy anything after this version, I don't want it to get any traffic, right? So I want anything after this to be silent deploys, basically. That's what I'm saying here. So let's actually do this. First, let's create our named revision. So in here, what I'm going to do is I'm going to deploy v1 again, but this time my version 1, you can see that it has a version 1 predictable name, right? So, and with this name, I can do traffic splitting. So that's why I deploy this. And if I do a curl again, you will see that we'll go back to version 1. Great. Now, let's deploy the next version, the version 4. So for that one, we do the same thing. And this creates the version 4 for my server revision. So the revision name is again predictable. But as if you remember, anything I deploy after version 1 should not get any traffic right now, because that's the rule that we have. So if I do a curl again, you see that it says version 1, right? So I deployed version 4 silently, but it's not getting any of the traffic. If I want to test version 4, I'll come here and then add latest dash. And then if I do that, then I can get to version 4. So I can test version 4, make sure it works. And then once I'm happy with it, I can start sending traffic to it. Now, how do I send traffic to it? Again, you go back to your service definition. And in here, yeah, we deployed version 4. In here, you just go to your traffic splitting rules. And here, I'm basically saying that I want my name revision 1 to get 50% of the traffic. And I want my name revision 4 to get the other 50%. And anything else I deploy after that should still not get any traffic. So I'm doing 50% traffic splitting. Let's do that, and let's also copy this and send some traffic. So let's copy this and service v1, v4. So now you will see that there's no new pods or there's no new revisions or anything like that. All we did is we updated route to do 50% traffic splitting. And now if we send, oh, sorry. Well, I guess I can do curl manually. So if I do this, now you see that now version 1 is probably scaling, version 4 is scaled up. And now if I do another curl, now this time probably version 1 will scale up. Yeah, so now they're both scaled up. And then if I keep doing it, now you should see 50% of the time is version 4, the other 50% is version 1, right? So this kind of stuff becomes really easy with Knative without you having to worry about the details of Istio, virtual services, destination rules, stuff like that. All right, I think that's all I wanted to show here. So you realize that we had auto-scaling already. So everything scales down to 0 when we don't use them, and then everything scales up to infinite because we haven't set any rules for that. But all of this auto-scaling is configurable. So what I have here is that, just to show you this, I created a dummy service called sleeping service that simulates some work. So when it gets a request, it sleeps for 4 seconds, and then it says hello world. So it kind of simulates doing some work. And let's use this as an example of auto-scaling. So what I did here is that I deployed my service and I set some auto-scaling rules that I'm going to explain. And then we'll see that it will auto-scale. But let me just start this first. And then as it's scaling up, I will explain what I did. So let me go back to my sleeping service. And then first, let's delete our hello world. So I'll say delete all my Knative services. And you can see that everything is terminating and gone. And then I will deploy my sleeping service. So now this creates the new sleeping service. And then I want to send some traffic to it. So let's use Fortio to send some load. So now the service is running, and then now I'm going to start sending some traffic to it. So as I do that, let me explain to you what I did here. So my sleeping service, as I mentioned, when it gets a request, it sleeps for 4 seconds, and then it responds back. Then I go to my service definition, and the default auto-scaling is concurrency-based auto-scaling, meaning each pod will get 100 requests before it scales up, right? But then this target defines how many requests I want per pod. So in this case, I changed the default 100 to 1, meaning each pod will get 1 request, and then it will scale up. I did that so that I can show you auto-scaling. So this is concurrency-based auto-scaling, but you can also use Kubernetes' CPU-based auto-scaling as well. So if you want that, you can also change it from concurrency to CPU. And also, the minimum scale and the maximum scale are configurable as well. So sometimes you really don't want your container to scale down to 0 because maybe it takes a while to scale up to 1. Maybe your cold starts are expensive. So for that, you can set minimum scale to 1. And if you do that, you will always have 1 pod running at all times. And then the maximum scale defines how many pods you should have at max. In this case, I'm setting it to 5, so I won't have more than 5 pods running. So that's what I did for my service. Then I pointed to my sleeping service, and then I started sending some traffic, and actually you can see that I already have 5 pods on my sleeping service running, right? So you can see that auto-scaling kicks in pretty quickly, and let's kill this, and then you will see that pretty soon they will scale down to 0. So all of this is pretty configurable, and you can also write your own auto-scaler and hook that up into Knative if you want to. All right, so that's auto-scaling, and now I want to talk about Cloud Run. So everything I show you so far is Knative on Kubernetes. So every time you have Kubernetes, you install Knative serving, you will have all of these features. But if you're running on Google Cloud, there's something called Cloud Run, which is the managed version of Knative. It's based on Knative. It works the same way, except it's much easier. So I just want to show you a quick demo of Cloud Run so that you get an idea of how it works and how is it different from Knative. So in order to use Cloud Run, first of all, it's a beta feature, and it's not in all regions yet. It's only supported in these 4 regions, last time I checked. So you want to make sure that you have a project in these regions. Then you need to deploy your container image to Google Container Registry. Google Container Registry, it's a kind of like Docker Hub, but within Google Cloud, so for your own Google Cloud project. So by using gcloud build submit and using tag, I'm basically saying that you run this within your Docker, where your Docker file is, and it takes your Docker file and it builds it in the cloud using Cloud Build, which is a service to build container images, and then it saves it to Google Container Registry. So we have it in Google Cloud, and then you use gcloud beta run deploy and point your image to deploy that image. Okay. So let me copy this. I already have my image on Google Cloud. So if you go to Container Registry, under Images, there's a Hello World image. And then under here, you see that there's a V1 image. So this is the image that I pushed a while back. So we'll just use that image for now. And if I come here, let's make this a little bit bigger, then I'm just going to say gcloud beta run deploy and just point to my image. Now, it's telling me, where do you want to deploy this? The fully managed version of Cloud Run, or Cloud Run on Google Kubernetes Engine, or a Kubernetes cluster. In this case, I want to go to the fully managed version one. My service name is Hello World. And now it's taking my image, it's creating a Knative revision, and it's routing traffic to that revision. So it's the same things that I show you, except the main difference in here is that I haven't created a cluster, I haven't installed Knative, I haven't installed Istio or anything like that. I just said, deploy this image that I have in Container Registry, and it does all of that for me. And now it's already deployed. So if we go back here, now instead of looking at Kubernetes Engine, we're going to look at Cloud Run, the managed version of Knative. And then you can see I have a couple of services. This is the one that I just deployed, I think. And you won't see it here, but by default, what you get here is that first, your service is deployed in region Europe West. You get a default dummy URL for your service, so you don't have to worry about setting your own domain. You get some graphs, so you request counts, request latencies, things like that. Now you can see the revisions of your service. You can see that this revision that I just deployed, it's getting 100% of the traffic. You can look at the logs. So Cloud Run is fully integrated with Stackdriver, which is a logging service for Google Cloud. And you can see all the logs under here. And you can see some details of your service. So in this case, my service it's an external service, which is a public service that anyone can get to. And it's unauthenticated, so you don't have to be authenticated to get to it. But all of this is configurable, so you can make internal services and you can make public services with authenticated users, stuff like that. But the thing is, if you look at YAML, it's still Knative, right? It's still a Knative service, except it's fully managed. And if you go to the URL, again, it's that very exciting Hello World message, but it's running on Cloud Run. So you can see that we try to make it really easy for you so that you can use Knative on-prem, but if you want to use it in the cloud, it's also easy with Cloud Run. Okay, so that's Cloud Run. Also, like so far, what I show you so far is that everything is public, right? Once you deploy a service, whether it's on Knative or on Cloud Run, you get a public URL. But maybe you don't want that. Maybe you want to have internal services where it's only visible within your cluster. You can do that with Knative. There's something called cluster local services. So all you have to do is you go to your service, and under here, you add a label called cluster local visibility label. And once you deploy this, and actually let's do it. I think I have this somewhere. So first let me delete my Knative service. And so I have a service local. And then when you look at the service local, it's deployed, but then the URL it has local default, right? It's not the same URL, because before we had the URL of, let's see, where is my URL? Before the URL was something like this. I set up nip.io as my dummy DNS, but now you can see that this has local, so it's not accessible from outside. So that's how you can make internal services if you want. You can also take an existing service. So let's imagine that you have an existing service and just add the label on the fly, and that will take that service and make it internal as well. So it's quite flexible. I think that's all I want to talk about serving. I also have some examples about, Twilio. I don't know if you guys know Twilio. It's a really cool phone and SMS application. So you can integrate that with Knative if you want, because as long as you have a public URL, Twilio can call that. You can use gRPC with Knative, so I talk about that as well, but I won't show it here because we don't have that much time. Next, I want to talk about Knative Eventing and what it does for you. All right. So that's Knative serving. That's the first part of Knative. The second part of Knative is called Knative Eventing. And Knative Eventing, what it tries to do is that it tries to connect a bunch of different event sources to different kinds of event consumers using some kind of flow in the middle. And I know this is a very general definition, but this is on purpose. I mean, Knative Eventing, it really tries to be this generic way of connecting different things together. It gives you kind of like the building blocks for doing that. And the way it works is that, well, first of all, the event sources that you can listen is a lot of different things. So you can listen AWS events, you can listen cron jobs or Google Cloud PubSub messages or cloud storage events or even Kubernetes events. So this is not the full list is here, but you can listen a lot of different kinds of event sources. And the way it works is that in Knative, there's this sources. They're actually source importers. So they import the external sources into Knative. Then once these events are in your Knative cluster, they go to something called broker. Typically, every namespace has a single broker that will receive these messages. Then these brokers will eventually pass these messages into services. These services, they can be Knative services, or they can be Kubernetes services. Anything that can be addressed can be called, can be passed the message to, because in the end, the events ends up going as a post call. So the broker will pass it to the service, either Knative or Kubernetes, but before it does that, it passes them through what's called a trigger. A trigger, it basically connects the broker to the service, but at the same time, it also does some kind of filtering so that not all services get all the messages, right? So you have broker for the namespace, trigger for filtering, and the actual service that actually gets the message and does something with it. Now, the service can do something and finish with the message, or it can put it back to broker if it wants and pass it to other services as well. So you can change things as well. And I should also mention that all these events coming into your cluster, they're all different kinds of events, right? They're not one type of event, but eventually they get converted into cloud events. This is the open source CNCF definition of events. So your events will have some kind of metadata that you expect, like ID and time and things like that. But then the data of your event will have the actual event that you want, and the broker will get these cloud events, and then from then on, it will be all cloud events that you have to deal with in your code. What I want to show you here is that I actually have one example. Well, I have many examples, but this is just one of them that I want to show you so that you get an idea of how these things work. So what I want to do here is that in Google Cloud, there's something called Google Cloud Storage. It's a place where you can save any kind of files you want. And then, in Google Cloud Storage, there's this notion of buckets. It's like a place where you can save files. And then you can specify, you can enable notifications on the bucket. So user saves an image to a bucket that sends a notification to a Google Cloud PubSub topic. So this is kind of like a queue where it will receive events that something happened in the bucket. Then I'm listening that topic in Knative. So Knative Eventing will pull that event into Knative, then it will pass it to a Knative service, and then the Knative service will make a call to Vision API. Vision API is a machine learning API that can be used to classify images. So in this case, what I'm doing is that when user saves the image, we will make a call to Vision API with the URL of this image and get the labels out of the image and just log it out, right? But the key point here is that you're connecting a cloud storage event to Vision API using Knative Eventing in the middle, right? And this Knative Eventing, it runs on Google Cloud, but it doesn't have to. It can run anywhere you want. So to set this up, let's see where I have this. First, you need to create your code. So again, I have C# and Python because those are the languages I like, but you can do it in any language you want. But just to show you briefly, what I'm doing is that when I get a request, so in my code, I get my event, then I look at the type of my event. So when an image is saved, it's storage object. And then I only look at those events. Then from that object, I extract the URL of my image, and I construct the Google Cloud Storage URL from that. And then this is the key part of it, basically. I have a method called extract labels async. This creates a Vision client. So this is the client I use to talk to Vision API. And I just say, extract labels from this image, and I just pass in the image URL. And then I also pass in 10, meaning give me 10 labels from this image. And this uses machine learning, and it extracts the labels out of the image. Then I order the labels by score, because each label has a certain score. So I take the first top, top 10. And then I also make sure that the score is high enough, so it's like 50%. And then I just return those labels, and I log them out. So that's what I do here. Again, like we need to create a Docker file because everything is a container in Knative. So this is my code. Let's go back here. Then I build my image. Then I create my service. So this is just like before, except I point to my Vision service. Then I create my service. So this basically makes my service running. But now I need to create the actual thing that reads the messages into Knative. Depending on what you are reading, there's different places and different things that you need to create. For example, in this case, we are reading PubSub messages from Google Cloud project. So for that, there is something called pull subscription that you need to create. And in this pull subscription, you basically give it a name, and you give which topic you want to listen. In this case, the topic name is testing. So that's where the storage events will go to. And then you also need to specify a sink. In this case, my sink, it's a service, but it's a Knative service, right? Because I'm using the Knative API. And I'm pointing to the name of my service. This could be a Kubernetes service as well. And in some examples, I show how to do a Kubernetes service. But I think Knative services are easier, so that's why I'm using Knative service here. So I create the pull subscription, and actually let's do that because it takes a little bit of time to get started. Eventing, Vision. So let's create the service first. Oh, no, sorry. This is Kubernetes service. I have a Knative service. So this creates a Knative service and pull subscription. And this is the thing that will read the PubSub messages into Knative. Now, if you do kubectl get pods, you'll see that I have the Vision that's running, and then I have a couple of pods for the pull subscription. I always get this crash loop back off thing, but I think it means if this is running, it should be okay. So now the messages are being listened in Knative. Then I basically go to my bucket, enable notifications on my bucket, and then I won't bore you with the details here, but then we need to, I did this already, I need to basically trigger this event. But before I trigger, let's look at our pod. So let me actually copy this. So this is the pod on my Vision. So let's look at the logs of this pod. You can see that my vision service is waiting for something to happen. So to trigger this vision, we need to save an image to the bucket so that triggers the whole chain. So let's do that. So I go back here, and under here, go to storage, and Knative bucket. This is the bucket where I save things. I already have a picture here, so let me upload another picture. Knative Eventing, vision pictures. This is a picture of myself, as you might see. Now, this is being uploaded to the bucket. Once it's uploaded to the bucket, it's quite fast. It will trigger a pops-up message to a topic, and the topic is being listened by Knative. It will pull that event in, then it will go to Vision service, and then from the Vision service, we make a call to Vision API. So if all of that worked, which seemed like it worked, you can see that the logs on my Vision service, it got the content, and then from there, it extracted the storage URL, which is my image, and then it called the Vision API, and now this says this picture is labeled, forehead, chin, facial hair, beard, blah, blah, blah. So this is me, basically. It's a silly example, as in all of my examples, but it shows you the point of connecting basically cloud storage to Vision API using eventing in the middle. And you can do many things like this using Kinetic Eventing. Okay, so I think that's all I want to. I have some other examples, but again, we don't have that much time. So let's move on. All right. So the last part of the talk is building. And what I want to talk about is Tecton pipelines, but I won't talk too much about it because it's not really part of Knative anymore. But I think it's still worth mentioning. And if you're interested in this, as I mentioned before, there's a talk in the afternoon on much more on Tecton pipelines than what I'm going to show you here. But before Knative 0.8, there used to be something called Knative Build. And Knative Build was all about going from your source code to a container image in a repository, right? So that you can use that image from your Knative services. Now, when you think about building container images, they're basically some pipeline, right? Some pipeline where you do some tasks. So from that, a new project was born called Tecton Pipelines. And once Tecton Pipelines moved out of Knative, Knative Build went away. But you can still use Tecton Pipelines with Knative, and that's what I want to talk about here. Now, in Tecton Pipelines, it's basically a way of running pipelines on top of Kubernetes. This can be anything really, like anything that you want to run, it will be run on Tecton. But you can also use it to build container images, go from source code to a container image. And Tecton Pipelines has some primitives, so it has this notion of task. Task is something that you define whatever you want to do, like in this case, building container images is a task. Then from the task, you go to a task run. Task run is kind of like an invocation of the task with some inputs and outputs. For example, if you are building container images, the task run will have input as your source code and output as your container image. And it will refer to the task, right? So it will just use the task with those inputs and outputs. Then you can chain multiple task runs into what's called pipelines. And you can also use service accounts. For example, on Docker Hub, you need to be authenticated with Docker Hub to push images. So for that, you would create a service account. So Tecton is very good for that. Let me show you a couple of examples. So for example, here, if you are using Knative Build, basically build became task run, build template becomes tasks, stuff like that, but you probably don't care about this anymore because it's old. But to install Tecton pipelines on top of your Kubernetes cluster, you just point to a YAML file, just like any other Kubernetes things. And then once you have Tecton, let's actually make sure that our Tecton is installed. Hopefully I remembered that. Yes, so I have my Tecton pipelines running. And then, as I mentioned, everything starts with a task. So in this case, to create a task, let's do something simple. I'm not going to run this, but I just want to show you here. Here I'm creating a task, giving it a name, and then the steps on my task is basically just saying echo. It just does an echo with this argument hello world, right? That's my task. And then to run this, I create a task run and then point to my task, right? And to basically invoke these, first you create the task, again kubectl apply, and then kubectl apply task run will actually run it. and then you can look at the logs and see that the task actually run. So that's the hello world example of Tecton. But what I really want to show you here is that using Tecton for a build. So for example, let's say you want to build a container image and push it to Google Container Registry. How can you do that? Well, first, you need to create a task. And in this task, I am using something called Canico. Canico, it's an open source tool to build container images within your Kubernetes cluster. So here I define the task, and then somewhere here I point to Canico, and then I also define some things that Canico expects about where to find the Docker file and where to save the Docker file once I build it, stuff like that. I won't bore you with the different details, but basically this task defines all the details of how to build an image using Canico, right? And I think let's see if I have this task. So if I go here and say kubectl, well, let me go to the right folder first. So if we go to build and kubectl get task, let's see if so I don't have any tasks. So first I need to create a task, and task build Docker images from Git source. Yeah, that's, and then if you do a task again, so now I have this task ready that I can use from any of my task runs. Now to run this, we need to create a task run. But before the task run, we need to specify some pipeline resources. So these are the things that my task run can use to run the task. In this case, one pipeline resource is what I want to build. So this points to my GitHub tutorial. This is what I want to build. And then the other pipeline resource is where I want to push my image. And in this case, my image URL is gcr.io, so Google Container Registry, right? So these are my inputs that I'm going to use later. Then I define my task run, and then in the task run, the input is my Docker source, and then the output is my image location that I want to push that I defined. So I'm basically referring to the pipeline resources that I just defined. And then I'm also pointing to the task reference that we defined, right? So to run this, let's copy this. Oh, sorry. And then this, first of all, these pipeline resources, I defined them before, so they're unchanged. And the task run, it's already running. So this is now actually building my image. And if I actually go here and say kubectl get pods, you should see that there's a build, hello world build that's running. Now it's doing the build, right? And similarly, let me kick off another task run. And this task run is build hello world Docker. So this time I'm going to build an image and push it to Docker Hub. Again, the pipeline resources are, this is unchanged because my source code is the same, but my output is going to be Docker Hub, so that this is created, and then this task run is also created. Now, the difference in Docker Hub is that, let me close this. The difference in Docker Hub is that in Docker Hub, you need to be authenticated so that you can push images. And to do that, you need to create a service account and use that service account. Now, for the service account, first you create a secret. This is just a Kubernetes secret with your username and password of Docker Hub. And then you create a service account that uses that secret, right? It refers to it. So I create both of those. And then in my task run, I do exactly the same thing, except I have this service account section where I point to my service account. So with this, I will be authenticated with Docker Hub, and it should be able to push my image. So let's actually see what's happening. So let's look at the pods. Yeah, you can see that they're both running. I think I don't have that much time to wait to finish this, but what I want to show you is that basically once this is done, you can look at the container registry, and then under hello world, you will see that I have one that has a tag Tecton. This was built October 9th, but basically in the end, this will be updated to the latest version, and that's how you can use Tecton pipelines. All right, yeah, I think that's all I have. So as I mentioned, everything I talked about is on GitHub, so feel free to go there. Knative has a website, knative.dev, that has much more than what I just described here. And if you want to run Knative on Google Cloud, cloud.google.com/run is the place to go. And I think we have a little bit of time for questions if we have any.
We do have a lot of questions.
We do, cool.
Yeah, probably we will not be able to take them all, but I found an interesting quote on Twitter.
Yeah.
So in 2014, we were thinking to adopt microservices to solve the problems with the monoliths.
Yeah.
In 2016, we were trying to adopt Docker to solve the problems with microservices. In 2018, we are adopting Kubernetes to solve the problems with Docker. Is it fair to say that we are now solving the problems with Kubernetes in 2019?
Well, I think it all depends on how you look at it. So the way I see is that Knative gives you a higher level API, so you don't have to care about the details underneath, right? So it's making it easier. So it's not necessarily the problems of Kubernetes, but it's just abstracting the details of Kubernetes for you. But I mean, if you see these as problems, then yeah, it is solving Kubernetes' problem, yeah.
I see. So yeah, there is plenty of questions, and we are probably going to take a couple of them only, but you know, there is a Q&A session afterwards, so
yes, so I'll be there in the
Q&A
Q&A
session.
session.
Ask more questions. And well, I will ask the first one because it's fair.
Yeah.
So what about the observability when the system is entirely built with serverless and the communication is event-based?
So I didn't show you, but Knative comes with a monitoring.yaml, and then with that you can actually see what's happening within your Knative services. So yeah, I mean, that you can totally use the Knative monitoring, or also you can use your own monitoring tools to look at Knative stuff. So that's all the stuff that you do with Istio for monitoring will also work out of the box with Knative.
I see. There are some questions like from different people who are asking basically the same, I think, about the persistence and the infrastructure.
Yeah.
So what about the infrastructure in Knative?
What do you mean by
so
that?
if I want to run MongoDB, use MongoDB, for instance?
Knative doesn't try to solve that kind of problems. Knative tries to solve like the code and how the code scales up and down and how the traffic goes to that code. But underneath, like, it doesn't do anything special for the persistent layer, basically. So whatever you do on Kubernetes and Istio for them, you can still do them and use them from Knative, but Knative doesn't do anything special for them.
I see. So there is another question. I'm not sure, maybe you have answered it during the session, but anyways, does Knative work only well with Istio? Or
no.
What if they are not using it, and for example, they want to manage the traffic through Nginx and Grass?
So right now, Knative supports Istio, Glue, and Ambassador. And I have this star that says no eventing, because at some point, if you wanted to use Glue, eventing wouldn't fully work. But I think this is not true anymore. I think it works now. But basically, gateways are pluggable, and I'm expecting more gateways coming in. I don't know the specific question on Nginx, whether you can't probably use that with Knative today, but it is pluggable, so I can expect things to plug in as we go forward with Knative.
I think there is another very great question, and we have 30 seconds. Is it possible to use non-HTTP services on Knative?
Well, you can use gRPC.
The specific question was about if it's TCP only.
I don't think so, yeah.
Okay. So we are out of time, actually, and there are more questions, and I hope people will follow you to the question and answer.
Yep, I'll be there.
Area. So thank you very much,
thank
and
you.
let's give the applause to the speaker.